Hey guys, and welcome back. Today we are talking about something called Sig Figs or significant figures in chemistry. But before we do that, I also want to do a really quick review of scientific notation with you as well. So scientific notation should be a review, but you will see a lot of values in this course that are written in scientific notation. So just a quick refresher will be really good for us today. All right, so scientific notation is, we use that when we're writing really, really big numbers or really, really small numbers, okay? In chemistry, we're going to be dealing with the size of atoms, the number of atoms, which can get to be very, very large or very, very small. And so knowing scientific notation is a really good skill set for us to have. So in scientific notation, we use decimals and exponents. So when we're looking at scientific notation, basically what you're doing is you're taking the value and you're changing it to a number between 1 and 10, and then you are adding exponents to ensure that the value is correct. So like, for example, here we have this value. So we've got 15 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros after it. Okay, so this would be the initial value. If we want to convert it to scientific notation, we have to put our decimal between two values that will give us a number between 1 and 10, okay? So we have a 15 here. If we put a decimal between the 1 and the 5, that gives us 1.5. That's a number between 1 and 10. That works for scientific notation. And then for your exponents, you're basically just counting the number of places you had to move that decimal. So here with this big number, this big positive number, our decimal is assumed to be right here. So to put our decimal between the 1 and the 5, we would have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places, okay? And that is where that 10 comes from. So 1.5 times 10 to the 10th power is our scientific notation. If the exponent is positive, that means it's a larger number. So we moved it to the left, it's a positive exponent. If we move it to the right, it's negative. So we're going to do the same thing. So even when we have small numbers, so really small decimals, we're still trying to get our first value between 1 and 10, and then of course our exponent can just be negative. So for example here we have 0.000053. We have a 5 and a 3. If we want to get a number between 1 and 10, it would have to go right here to give us 5.3. So then we just move our decimal and count how many times we have to move it, right? So 1, 2, 3, 4, 5. So 5.3 times 10 to the negative 5 would be our scientific notation. And again, this is a negative because we move the decimal to the right, okay? And that's just a refresher. If that is very confusing and you have no idea, you can definitely let me know and I can meet with you one-on-one and we can do a little bit more with scientific notation, okay? So let's do a couple practice problems here before we talk about Sig Figs. So we have 14,000 here, and we want to put this into scientific notation, okay? Well, the first thing I need to do is put my decimal somewhere where I know my value will be between 1 and 10, okay? Well, I have a 14. 14 doesn't work, but if I put a decimal right here, 1.4, that works because 1.4 is between 1 and 10, okay? So we'll have 1.4 times 10, and then we have to count how many we went over. So 1, 2, 3, 4. So we went to the left 4. So our scientific notation is 1.4 times 10 to the 4th. Okay? So now let's go in the opposite direction. We have 0.0043. Again, I want a number between 1 and 10 as my first value. So we're going to put our decimal point, whoops, sorry about that. There we go. Okay, so let me grab this again. So we're going to put our decimal point right here between the 4 and the 3, which will give us 4.3. And then our exponent, we know it's going to be negative because we're moving our decimal to the right. And we just need to count how many we moved it. So 1, 2, 3. So that's 4.3 times 10 to the negative 3. Okay? And that is your scientific notation for that particular value. Okay, again, this was just a really quick refresher, but if you need some more practice or you need some additional help, let me know and I'll be more than happy to help you with that. Okay? All right, so now that we've gotten a quick refresher on scientific notation, let's talk about today's topic, which is significant figures, aka Sig Figs. And that's how you'll hear me refer to them throughout the course. So a Sig Fig is the reliable digits in a measurement based on the precision of the measuring device. Okay, so these are the reliable digits in the measurement. All of these Sig Figs are coming from measurements. We use significant figures when we measure something. So that could be length, it could be volume, it could be density, whatever. It's a measurement of something and we need to know the Sig Figs for that measurement. So there are some rules we're going to figure out or follow in order to figure out the number of Sig Figs in a particular value, okay? So the first rule, non-zero digits are always significant. So if you have a digit in a value that is not 0, anything other than 0, it's always going to be significant. So let's take a look at some examples. Here we have 32,445. All of those are non-zero. 3 is not 0, 2 is not 0, 4 is not 0, 5 is not 0. So all of these are significant. So if I were to give you this number and ask you how many Sig Figs, you would tell me there's 1, 2, 3, 4, 5. There are 5 Sig Figs there because all of those numbers are non-zero digits, and if it's non-zero, it's always significant. Next up, we have 0.23435. Okay, so taking a look at this, I can tell this is 0. Okay, and there's going to be some rules for 0, so we're not going to worry about him right now. We're going to assume he's not significant because he is a 0. But 2, 3, 4, 3, 5, those are all non-zero digits. So this one has 1, 2, 3, 4, 5 significant figures. Okay, we don't count the 0 because zeros are not always significant. Okay, and I'm going to give you the rules for zeros here in just a minute. And finally, we have 2,348.23. Again, all of these are non-zeros. So there's 1, 2, 3, 4, 5, 6 Sig Figs there. Okay, there are 6 Sig Figs in that number. Okay, so zeros are weird, and they can come in 3 flavors, so to speak, or 3 scenarios that we have to know the rules for each one. So the first flavor is a leading 0, second is a captive 0, and then the third is a trailing 0. So let's look at the rules for those 3. So leading zeros precede non-zero digits, so kind of like that example that we just did. And they don't count. They are placeholders. So if you have a leading 0, they are not counted as a significant figure. So let's take a look at an example. Here we have 0.0023. They're leading because they're leading up to the non-zero digits. So here, these zeros do not count, and there are 2 Sig Figs. Okay? And here, again, we have same thing, 0.02334. These zeros are leading zeros. They don't count. And so there's only 4 Sig Figs here because there are 4 non-zero numbers. Okay, so 4 Sig Figs. Next up is our captive zeros. If you're held captive, you are, in between 2 things. So a captive 0 is held between 2 non-zero digits, and they always count as Sig Figs. Okay, so if you have a 0 in between 2 non-zero numbers, they are significant. So here we have 1.009. These zeros are held captive between these 2 non-zero numbers, and therefore they are significant. So this is 4 Sig Figs. And here we have 230,004. This is, again, these captive zeros in between. There's 1, 2, 3, 4, 5, 6 sig figs here, okay? So if the zeros are at the beginning, they don't count. If the zeros are in between significant figures, aka non-zero numbers, then they do count. Okay, and again, I know this is a lot of rules. That's why writing them down in your notebook is going to be really helpful. Okay, last but not least, we've got trailing zeros, and these are the tricky ones. So the leading and the captive zeros are pretty easy. The trailing zeros is normally where students can get a little bit tripped up. So these are zeros at the end of the number. They're only significant if there's a decimal point, okay? And this is why students get confused, because when there's a decimal point present, that means the zeros are significant, but if there's no decimal point, then they're not, okay? And this is for trailing zeros, so after significant numbers, okay? So for example, here we have the number 100. There is no decimal point here. These zeros come after a non-zero digit, and they don't have a decimal point. So these do not count as significant. So 100 only has one sig fig, okay? However, if we add a decimal place, then we do have to count these trailing zeros. So here we have a scientific notation example where we have 1.00. That's 3 sig figs, okay? Because we do have to count these zeros now that there's a decimal point. So trailing zeros only count if they come after a decimal, okay? And then 100 with a dot for a decimal, that is still 3 sig figs because, again, there is a decimal point to indicate that these two positions are significant, okay? So those are your rules you're going to follow, but just some general information on sig figs. They give you the information on the exactness of a measurement, and we only use them when we're measuring something, not counting, okay? So if you're counting a precise number, like say 36 students in the classroom, that's not a sig fig because it's not a measurement, it's an actual count, okay? So the last thing we have to talk about is what do we do if there's a mathematical operation? So if you have to add, subtract, multiply, divide, how do you calculate how many sig figs are there? With addition and subtraction, you have to have as many decimal places as the measurement with the least number of decimal places. So that means if you have, a set number of values, you're just going to round and report to the least number of decimal places. So let's take a look at that. So here we have an addition problem. So we have 12.11, 18.0, and 1.013. When you do math, you add, multiply, subtract, do all that first, and then get the sig figs and round at the end. If you round before, you're going to come off with the wrong answer, okay? So here we're adding these values. 18.0 has the least number of decimal places, okay? So it's got one place after the decimal, which means your final answer has to have one place after the decimal. Okay, so you add it up first and then round to your necessary sig fig, okay? When you're rounding, we follow general rounding rules. We're going to look to the right of the place we're rounding to. If it's less than 5, you round down. If it's greater than 5, you round up. And same thing for subtraction here. This 1.0 has the least number of decimal places, which means your answer has to be reported to one decimal place. And then for multiplication and division, the answer may contain only as many significant digits as the measurement with the least number of significant digits, okay? So here you have to figure out the sig figs in each one. So 4.56 has 3, 1.4 has 2, 2 sig figs is the least, so your final answer has to be reported to 2 sig figs. Same thing for division. Here we've got 1 sig fig. Here we've got 4. Your final answer has to be reported to 1 because there's only 1 sig fig, okay? So addition and subtraction, least decimal, multiplication and division, the least number of sig figs. And these are your